The first thing that we are seeing is a force can be broken down into two perpendicular again. Yes, so पहली चीज हम इसके बारे में देखते हैं. I'll explain it a bit as well. What is the one thing that you should be careful with? That the two components that you are breaking the force down into are perpendicular to each other, which means they are at right angle to each other. So if I have a ball that I'm kicking, for example, एक मेरे पास ball है. If I have a ball that I'm kicking and it is going in this direction, basically there are, and I've written here a force, but technically any vector can be broken down into two components, provide the fact that the components are perpendicular to each other. So basically, if I'm telling you this is the force that I applied on the ball, so I can obviously break down this force into two components, one being a horizontal component, I'm calling this Fx, and the other being a vertical component, which is Fy. And F is basically the resultant of the two components. Is this clear? So I can break down this force into two components, provided the fact that those two components are always perpendicular to each other. इसमें एक बहुत common case scenario that we usually deal with is this one. इसमें angle को भी देखेंगे. Now what if I have a slope which makes an angle theta with the horizontal. So yeah. And if I have an object on this slope, for example, it's a box, and that box has a weight which is acting vertically downward. Now, if I want to make two component of this force of the weight, how can I make the two components? One will be perpendicular to the slope, and one will be perpendicular to the box. One is perpendicular to the slope, and the other is parallel to the slope. Now this one, I'm drawing this one, the one that is parallel to the slope over here. Just for the sake of drawing, if this angle is theta, this angle is also theta. So this force is W cos theta using a simple right angle triangle, and this is W sin theta. Is this clear? ये वाली बात clear है कि अगर ये angle theta हो तो ये angle भी, इसमें कोई confusion तो नहीं है. You must have studied in physics as well. Not so I can prove it. For example, this angle is 50. अगर ये 50 है तो ये वाला कितना हो गया? 90. If this is 90, तो ये वाला कितना हो गया? 40. And if this is 40, then again this one ends up being 50. Is this clear? So you can break down a force into any two components, provided the fact that those two components are perpendicular to each other. Is this clear? And if you want to make the resultant from the two components, you can always use Pythagoras theorem, fx square plus fy square. So if I'm generalizing this, any force or any vector in that reference can be broken down. Horizontal is called, or generally one of them is fx cos theta. Fx f cos theta. It strictly matters on what your theta is, and fy अगर मैं कह दूं, that is f sine theta. And if I want to find f, I will find it through Pythagoras theorem. Fx square plus f y, which is my resultant force. A force जिसको मैंने दो components में I have broken it down. Is this clear till this point? So the two things that we have learned in this first part is a force can be broken down into two components provided the fact that those two components are perpendicular to each other. And if you have the two components, you can find the resultant force or the actual or the total force by using simply the Pythagoras theorem. Is this clear? Now, what about when in equilibrium? Very good. इसको थोड़ा सा इस तरह तो नहीं करते, but we will get there. So we'll say when in equilibrium, होता क्या है ऑब्जेक्ट? दो चीजें हमारे पास होती हैं. The object is either at rest or moving with constant velocity. So in that case, we will say the equations that we can make, there are different kinds of equations that we can make depending on the question. We can say that sum of forces up is equals to, because the resultant force is zero, there is no resultant force. इसी तरह we can say that so similarly we can say that sum of forces right is equals to sum of forces left. Similarly, we can also say that sum of forces down the slope is equals to sum of so there are different equations that we can make, but all of these equations can be made when we know that there is no resultant force and the object is obviously either at rest or moving with constant velocity. Is this clear? The third thing that we will see is contact force. Now, what is a contact force? Basically, it's a force between an object and the surface on which it is on. So I'll use a very similar image that we have just on. Very good. So now try to understand this. If I have एक inclined slope ले लेते हैं तो उससे समझना आसान हो जाता है. If I have an inclined slope with an angle theta, so if an object is on the slope, so basically there are two forces that are acting on the object by the surface. What are those two forces? One of them is the normal component or normal force as we call it. दोनों नाम हम उसको देते हैं, normal component or normal force. This is a force that is perpendicular to the surface. perpendicular to the surface. This is also called the normal component. It is also called basically contact force तो पूरी वाली होती है, but contact force का normal component या normal contact force. What is the other contact component of the contact force? Is the object is trying to move down the slope. There is a friction force that is acting on the object, which is against the motion. These two are the component of the contact force. These two are the very good. This is normal component, generally represented by R, and this is the friction component, which is represented by F. ये दो क्या हैं? They are the components of the contact force. One is the normal component and the other is the frictional component. The contact force है the force applied if the object was on the horizontal table, फिर तो the only contact force would have been the normal component. Is that right? फिर कोई friction नहीं होगी. Is this clear or not? So these are the components of the contact force. Is this clear? Okay, now there are another things that we need to understand. Then it is the concept of friction. Okay. If the question says friction is obviously a force between very good object and the surface between generally अभी हम हमारे example में ज़्यादातर it will be mostly between two solids. If the word says smooth, then there is no friction. So if smooth means no friction. Is this clear? Yes. Okay, now let's take an example. For example, if I have this chair and on the surface, and if I'm trying to push the chair, and the chair does not move, I'll show it to you even here on a figure so that you are able to understand. सबसे पहले तो friction अगर है, so the word that will be used is rough. क्या word use होगा? If I have this, and if I have a box on this surface, and if I'm trying to move this box and the surface is rough, obviously. For example, I apply the force of 1 Newton. And I see that by applying the force of 1 Newton, the object does not move. What is the friction acting on the surface? Okay. Friction on the surface. मैंने 1 न्यूटन का धक्का लगाया तो हिला ही नहीं. So what is the friction at that point? 1 Newton. If I would have applied the force of 2 Newtons and I would have observed that the object still does not move, friction be 2 Newtons. Okay, now if I scale it up and I say that I apply the force of 10 Newton and the object still does not move, what will you say the friction is? 10 Newton. Friction is against the motion. Now, if I see that I apply the force of 12 Newton and the object is about to move, so what is the friction at that point? The object is about to move. बस अब move करने ही वाला, you are about to overcome the friction. The friction will also be 12 newtons. If I would have applied any force greater than 12 newtons, for example, a 12 Newton it was about to move, right? If I apply 15 Newton, then 15 Newton will be acting forwards. The friction still would be friction, जैसे 12 एग्जाम्पल ले रहा हूं, वो 12 पे ही रुक जाएगी. समझ आ रही है बात? If I apply 1 Newton, friction is 1, 2, 2, 3, 3, 10, 10, 11, 11, 12 पे the object is about to move. Friction is 12. And if you apply 15, 10, 15, 20, 30, any force greater than 12, the friction एक limit तक बढ़ती है, उसके beyond the friction does not increase. Is this clear or not? समझ आ गई बात? तो this is an example. So friction के लिए हम दो चीजें use करते हैं. We can always say that friction is equals to mu r. Mu is the coefficient of friction, or we can also say that friction is less than equal to mu r. म्यू आर वो लिमिटिंग, वो मैक्सिमम वैल्यू ऑफ फ्रिक्शन होती है कि फ्रिक्शन यहाँ तक बढ़ेगी, एंड उससे पहले इफ द ऑब्जेक्ट इज स्टेशनरी, अगर वो ऐसे ही बैठा हुआ है, इट इज नॉट मूविंग, सो देयर इज नो फ्रिक्शन. फ्रिक्शन विल ओनली बी देयर व्हेन देयर इज एन एक्शन. तो फ्रिक्शन रिएक्शन में आएगी फिर. इज दिस क्लियर? इफ आई ओनली एक्ट 2 न्यूटन, तो फ्रिक्शन को 12 होने की जरूरत नहीं है. फ्रिक्शन 2 न्यूटन इज इनफ. समझ आ रही है बात या नहीं आ रही है? फिर इक्विलिब्रियम में नहीं रहना चाहिए. सो फ्रिक्शन इज अगेंस्ट द मोशन. एक लिमिट तक फ्रिक्शन बढ़ती है, उसके बियॉन्ड द फ्रिक्शन डज नॉट इंक्रीज. एट मैक्सिमम लेवल एफ इज इक्वल्स टू म्यू आर. म्यू इज द कोएफिशिएंट ऑफ फ्रिक्शन. इज दिस क्लियर? एंड फ्रिक्शन विल ओनली बी अप्लाइड व्हेन द सरफेस इज वेरी गुड. Coefficient of friction. Coefficient of friction. R is the normal component and mu is the coefficient of friction. F is friction.